Hey everyone, welcome to the Explainer. So today we're taking a deep dive right into the heart of C++. If you've ever, been completely frustrated by those incredibly strict compiler rules when you're just trying to work with your own custom objects, well, you are definitely in the right place. We're going to take those rigid rules and literally transform them into a super practical, really powerful tool that makes your code, honestly, just dramatically cleaner and way more intuitive.
Okay, let's dive into this. Our agenda for today. First up, the custom object problem. Then, what exactly is operator overloading? Next, we'll look at operator syntax and hierarchy, followed by visualizing a real-world currency example. We'll wrap up with pointers and memory rules. And finally, the absolute golden rules of overloading.
All right, part one, the custom object problem.
So here is a super frustrating limitation that pretty much every C++ developer hits when they first start building classes right out of the box. Imagine you build this beautifully structured custom class. Maybe you want to track bank accounts or, I don't know, 3D coordinates. You create two instances of it, you throw a simple plus sign between them, you confidently hit compile, and bam, the compiler just throws its hands up and spits out an error. Like, why? Why does it do that?
Well, it comes down to this. C++ has these deeply ingrained, predefined ways of handling its built-in data types. It intrinsically knows that adding two integers, like 10 and 20, just means standard integer addition, right? It perfectly understands that 10.5 plus 20.6 needs floating point math. But your custom classes, they are totally left stranded. Out of the box, standard operations on custom classes are strictly limited to basic assignment, basically just copying one object to another, and member selection, like pulling a variable out of the class. If you try to force mathematical operators on them, the compiler is essentially just looking at you going, I have absolutely no idea what you want me to do with this.
Which brings us to part two. What is operator overloading?
Luckily, C++ gives us a total game changer to solve this exact headache. It's called operator overloading. Basically, this is your ability to extend standard operators, addition, subtraction, multiplication, division, so they work perfectly seamlessly with your own user-defined data types. It's literally like teaching the C++ compiler new tricks. You are explicitly defining the exact step-by-step action an operator should take when it bumps into objects from your specific class. To pull this off, you define the entire behavior, meaning you write the function's header and its logic-packed body. And when you nail it, your custom objects start behaving exactly like those native built-in data types.
Moving on to part three, operator syntax and hierarchy. Now, what's really interesting here is the explicit syntax formula you need to actually make this work. Notice the reserved word operator. That word is your flag to the compiler. It says, hey, pay attention to this. You start by specifying a return type, write the word operator, and then immediately follow it with the actual symbol you want to overload, like the plus sign, for example. After that, you just drop in your formal parameter list in parentheses. At the end of the day, it behaves exactly like any other value returning function. You just pop this declaration right into your class definition and then write out the function definition to map the logic. Simple as that.
But, the C++ ecosystem for these operators is incredibly hierarchical. It's kind of like a massive family tree. You can see operators are split into those that are overloaded and those that aren't. And if you go down the overloaded branch, you have some serious architectural choices to make. You can implement your overloaded operator as a member function attached directly to the class, or as a non-member function. And actually, if you choose the non-member route, you then have to decide, does this need to be a friend function, which grants its special VIP access to your private data, or a non-friend? This entire tree dictates exactly how your code is allowed to interact with the private inner workings of your objects.
Okay, part four, visualizing the currency example.
Let's take all this abstract syntax and ground it in a real concrete scenario. For a second, I want you to act like the C++ compiler. Let's peek under the hood, into the computer's memory. We'll start with our first operand, an object called amount1. This is an instance of a custom currency class we built. Inside its little memory block, it holds two integer values, 10 for the dollars and 50 for the cents. And crucially, it also holds the blueprint for our operator plus member function. Next up, we introduce our second operand, amount2. This object is structured the exact same way, and it also happens to be holding $10.50. The grand goal here? We want to seamlessly add amount2 to amount1, using just a standard, beautiful plus sign in our main program, instead of having to call some clunky, ugly function like add amounts.
And here is where the magic actually happens. When the compiler sees that plus sign sitting between two of our currency objects, it immediately triggers that specific operator plus member function we defined. Inside the logic, it takes the dollars from amount 1 and adds them to the dollars from amount 2, which, by the way, gets passed in as a parameter. Then it does the exact same thing for the cents, but check out what happens next. It packs those newly combined totals into a brand new temporary currency object, usually just called temp, and then it returns that temp object right back to the program. And this brilliantly illustrates what's happening completely behind the scenes. We can see the exact state of that temporary object sitting right there in memory. Now, because 50 cents plus 50 cents equals a full dollar, our internal class logic is smart enough to handle the arithmetic carryover. So the compiler generates this temporary object holding exactly $21.00. It literally only exists just long enough to bridge that tiny gap between the addition happening and the final assignment. To wrap up this visual journey, that temporary value of $21.00 is cleanly and seamlessly assigned to our final destination object, which we've named total. The compiler sweeps in, cleans up the temporary object, and your main code is left with a perfectly calculated total. And all of this was kicked off by simply typing amount 1 plus amount 2. I mean, how elegant is that? It's clean, it's highly readable, it's just great code. Moving right along to part 5, pointers and memory rules. Now look, while operator overloading is insanely powerful, we definitely need to talk about a massive safety warning. In C++, this is known as the rule of 3. Remember how the default assignment operator basically just copies member variables directly from one object to another? Well, if your class happens to use pointer member variables, that default behavior is dangerously inadequate. Seriously, it's a disaster waiting to happen. It just copies the memory address, which means you end up with two separate objects pointing to the exact same piece of data in memory. Eventually, one of them tries to delete it, and boom, your program crashes. So the rule is, if you use pointers, you absolutely must explicitly overload the assignment operator to perform a deep copy. And to complete the rule of 3, you also have to write a custom copy constructor and a destructor to safely manage all that dynamic memory. Finally, part 6, the golden rules of overloading. So, the absolutely crucial takeaway here is that while overloading gives you a ton of power, it is definitely not the Wild West. There are guardrails. For starters, you cannot just invent entirely new operators. No making up your own symbols. Sorry. You also can't change the foundational meaning of an operator for the built-in types. Like, you can't force the plus sign to somehow perform subtraction on two integers. On top of that, the overloaded operator must involve at least one operand that is a user-defined type. You simply can't hijack the math between two standard ints. And finally, there are a handful of core structural operators that are strictly off-limits. You cannot overload the member access dot, the scope resolution operator, the ternary conditional operator, or size of. Those are completely untouchable. But by mastering these rules and really getting comfortable with the syntax, you unlock this incredible ability to write code that actually speaks the language of your specific domain natively. No more chaining together clunky function calls just to do basic arithmetic on your custom types. So I want to leave you with a thought to chew on. Now that you know how it works under the hood, how will you use operator overloading to simplify the architecture and supercharge the readability of your own custom code? Thanks so much for joining me for this explainer. Keep experimenting out there and happy coding.